This is a brief review of some, but certainly not all, of the most infamous earthquake events to occur in recorded human history. In addition, we will also talk about some of the areas in the United States that are prone to earthquake activity. As with most Geology 101 topics, we could spend the entire semester on this subject. This color-coded map of earthquake magnitude should look familiar. It's a roadmap for some of the places that we will discuss today, like Alaska, Chile, Japan, etc. Buckle up. It's time to rock and roll. The U.S. Geological Survey, or USGS, maintains an earthquake hazards program. The USGS provides a great deal of earthquake-related information, and much of it is available on this website. This is a map of earthquakes with magnitudes greater than 6 that have occurred between 1900 and 2017. You can plainly see that most of the quakes occur on what we now know as tectonic plate boundaries. Not only that, but the highest magnitude events occur at convergent plate margins, specifically subduction zones. This chart shows earthquakes of magnitude 8 or greater that have occurred since the year 1900. The colors indicate the continent, and the legend counts the number of quakes for each. The sizes of the bubbles are linearly proportional to their respective fatalities. The 1960s witnessed the two highest magnitude events, but the period between 2000 and 2015 included the two deadliest earthquakes to occur in the last 100 years or so. Let's look a little closer at the highest magnitude earthquake events. We'll start with the 1960 Chile earthquake, also known as the 1960 Valdivia earthquake. This 9.5 magnitude subduction zone earthquake occurred near Valdivia, Chile, where the oceanic portion of the Nazca Plate is subducting beneath the continental portion of the South American Plate. The main shock lasted around 10 minutes and generated a number of geologic hazards. These included large landslides that occurred across the region and tsunamis that traveled across the Pacific Ocean basin. This quake was a 12 on the modified Mercalli intensity scale, which is on the catastrophic upper end of the scale. Fatalities range from 1,000 to 6,000, with 2 million people left homeless. Concepcion, one of 3 major metropolitan areas in Chile, has a current population of almost 1 million. Frequent seismic activity occurs in this area, and the city has been devastated by several high-magnitude earthquake events, including 1939 8.3 magnitude Chilean earthquake, followed by a 7.6 magnitude event in 1953. And of course, the gigantic 9.5 magnitude event in 1960. The epicenter of the 1960 Valdivia earthquake was to the south, at Lumico, between Lebu and Temaca. This event was a so-called megathrust earthquake, resulting from the subduction of the Nazca Oceanic Plate beneath the continental portion of the South American Plate. "800 kilometers of fault rupture was associated with this earthquake. Resulting tsunami waves were locally up to 25 meters in height, with the main tsunami wave traveling across the Pacific. 10-meter waves struck Hilo, Hawaii, killing 61 people, and 180 perished in the Japanese islands of Honshu and Hokkaido. Numerous landslides occurred in the steep-sided valleys in the nearby Andes, and an eruption of the Cordon Col volcano was likely triggered by the earthquake, with the eruption occurring only 38 hours after the main shock. The 1964 Good Friday earthquake, or Great Alaskan Earthquake, was a 9.2 magnitude subduction zone earthquake near Anchorage, Alaska. This earthquake occurred where the Pacific Oceanic Plate is subducting beneath the continental portion of the North American Plate. The main shock lasted 4 to 5 minutes, and as with the 1960 Chile earthquake, generated a number of significant geologic hazards. These included ground deformation, large landslides, and tsunamis that traveled across the Pacific Ocean basin. This quake was an 11 on the modified Mercalli intensity scale, which is considered extreme. There were 131 fatalities in this earthquake event. This is Anchorage, Alaska, currently home to about 400,000 people. The 1964 9.2 magnitude Good Friday earthquake epicenter was about 125 kilometers to the east, along the northern margin of Prince William Sound. The earthquake was a megathrust event where the Pacific Oceanic Plate is subducting beneath the continental portion of the North American Plate. This quake was an 11 on the modified Mercalli intensity scale and generated ground shaking, landslides, and subsidence that was considerable in the Anchorage area and along the coast. 9 people died as a result of the earthquake, but over 120 perished as a result of the related tsunamis. Over 10 meters of vertical displacement occurred on the seafloor, producing a main tsunami pulse and about 20 smaller, more localized tsunami. The smaller tsunami were landslide generated and caused significant damage and fatalities. The main tectonic tsunami wave affected coastlines from Alaska to Oregon, California, and Hawaii, and reached Australia and New Zealand in 15 hours. The largest tsunami wave was recorded at Shoup Bay, Alaska, with a height of 67 meters. The 2011 9.1 magnitude Tohoku earthquake was a subduction zone earthquake that occurred offshore of the Japanese island of Honshu. This earthquake happened where the Pacific Oceanic Plate is subducting beneath the oceanic portion of the Eurasian Plate. The main shock lasted around 6 minutes and generated tsunamis that locally reached heights of 40 meters. This quake was a 9 on the modified Mercalli intensity scale, which is considered violent. The tsunamis killed around 16,000 people and caused a major accident at the Fukushima Daiichi nuclear power plant. The Tohoku region of Japan's largest island, Honshu, is a generally mountainous area consisting of 6 prefectures, including Fukushima, Miyagi, and others along the Pacific coast. The epicenter of the 2011 9.1 magnitude Tohoku earthquake was located 130 kilometers east of Sendai in the Pacific Ocean. This subduction-related megathrust earthquake originated at a depth of 29 kilometers as a result of the subduction of the Pacific Oceanic Plate beneath the Okhotsk Plate and produced a 500-kilometer-long fault rupture zone. The largest city, Sendai, has a population just over 1 million and is located on the Sendai Plain. The 6-minute earthquake event, a 9 on the modified Mercalli intensity scale, was the most powerful ever recorded in Japan and spawned a massive tsunami, reaching heights up to 40 meters in the Miyako area. Tsunami waves swamped seawalls and inundated the Sendai Plain up to 10 kilometers inland. Most notable was the 14-meter wave that overwhelmed and severely damaged the Fukushima Daiichi nuclear power plant. This earthquake event resulted in almost 20,000 deaths, 2,500 missing, and at least $360 billion in damage. Now let's look at some of the deadliest earthquakes of the last 100 years or so. This is a global seismic hazard map showing the geographic distribution of the peak ground acceleration, or essentially ground movement, with a 10% probability of being exceeded in 50 years, computed for reference rock conditions, of course. Essentially, this means the probability of a large earthquake in the next 50 years. Note that most of the higher value areas correspond with tectonic plate boundaries, but some lower end hazards are also present in areas away from active plate boundaries. For example, Eastern North America, Africa, Australia, etc. 1976, Tangshan, China. This earthquake event included two large earthquakes of magnitude 7.6 and 7.0. The epicenters were located in the heavily populated city of Tangshan near Beijing in northeast China. Tangshan is located on soft alluvial sediment, which facilitated the destruction of 85% of the brick, adobe, and wood buildings. 242,000 fatalities occurred as a result of this earthquake. 2004 Indian Ocean. This was a massive 9.1 magnitude earthquake event offshore of Sumatra. It was related to seafloor fault displacement, where the oceanic portion of the Indian plate is subducting beneath the Burma plate. Ground shaking lasted 8 to 10 minutes and generated tsunami averaging 10 meters in height. This was the deadliest natural disaster of the 21st century, with 228,000 fatalities in 14 countries. The 2004 Indian Ocean earthquake was a 9.1 magnitude subduction zone earthquake, or megathrust earthquake, whose epicenter was off the coast of northern Sumatra, Indonesia. It resulted from the subduction of the oceanic portion of the Indian plate beneath the Burma microplate. This quake occurred at a depth of 30 kilometers and had an estimated 1,600 kilometers of fault rupture, with about 15 meters of displacement along the Sunda Trench. This third largest earthquake ever recorded produced several massive tsunami waves up to 30 meters in height that inundated the coastlines of Indonesia, Thailand, and other countries in the Indian Ocean area. The tsunami first devastated the coastline of northern Sumatra's Aceh province. At Mulabo, the sea receded 500 meters before the arrival of the tsunami waves. Tsunami heights along the west coast of Aceh were 15 to 30 meters, which exceeded the heights of the coconut trees. Inundation here was about 5 kilometers inland. Eyewitnesses described 3 large waves, likening the dark-colored waves to black giants as they traveled inland. Farther north, the city of Banda Aceh, with a population of about 250,000, suffered massive damage from these powerful waves. About 2 hours later, southern Thailand also received the brunt of the tsunami's force, with waves up to 10 meters high breaking in Khao Lak. The waves then progressed across the Indian Ocean, reaching Australia in 5 hours, and the African coastline after 7 to 8 hours. Almost 230,000 people from 15 countries perished in this event, more than half from Indonesia. There were also about 44,000 people missing, with almost 2 million people displaced. 2010 Haiti. This was a 7.0 magnitude earthquake on the Caribbean island of Hispaniola. It occurred along the transform boundary between the Caribbean and North American plates. This earthquake caused major damage in Haiti's capital, Port-au-Prince, and resulted in a minimum of 100,000 fatalities in both Haiti and the Dominican Republic. The 2010 7.0 magnitude Haiti earthquake occurred in the vicinity of the transform boundary between the Caribbean Oceanic Plate and the oceanic portion of the North American Plate. This earthquake had a depth of about 13 kilometers, and the epicenter was on the island of Hispaniola, about 25 kilometers west of Haiti's capital, Port-au-Prince. Strong ground shaking produced devastating effects, up to 10 on the modified Mercalli intensity scale, in the Port-au-Prince area. At least 100,000 perished in this seismic event, although the region was spared a major tsunami due to the inland location of the earthquake and the fact that there was no major oceanic fault rupture. This is in stark contrast to the 2004 Indian Ocean event and the 2011 Tohoku, Japan earthquake. What about seismic activity in the United States? Well, most seismic activity in the U.S. occurs in Alaska, Hawaii, and along the West Coast. And much of this is related to the active tectonics of each region. The mid-continent region also sees significant seismicity. However, this takes place along former tectonic structures buried underneath younger geologic cover. Let's look at each of these areas in detail. Alaska is the most seismically active area in the U.S., by far. Seismicity occurs mostly in southern Alaska, where shallow to deep focus earthquakes are related to both the subduction of the Pacific Oceanic Plate beneath the North American Plate and the transform movement between the Pacific and North American plates. Many high-magnitude earthquakes have been recorded, with 10 having magnitudes greater than 7.0. These include the 9.2 magnitude 1964 Good Friday earthquake and the 8.6 magnitude 1946 Aleutian Islands earthquake. And there have been plenty more. California is next in line on the earthquake list. The earthquake activity is mostly transform related, with a lesser amount of subduction related activity as well. Shallow focus seismicity occurs along the San Andreas and other similar strike-slip faults as the Pacific Plate moves northwest past the North American Plate. In northernmost California, subduction of the Gorda Plate beneath the North American Plate not only forms the southern part of the Cascades continental volcanic arc, but also all the earthquakes associated with it. This region also has had many high-magnitude earthquakes, greater than 7.0. They include the 7.9 magnitude 1906 San Francisco earthquake, the 7.9 magnitude 1846 Fort Tejon earthquake, the 7.3 magnitude 1992 Landers earthquake, the 6.9 1989 Loma Prieta or World Series earthquake, etc., etc., etc. The Big Island of Hawaii also sees a lot of earthquake activity. This is mainly due to the Hawaiian hotspot, where the Pacific Plate is moving northwest over the Hawaiian mantle plume. Seismicity decreases dramatically with distance away from the hotspot. On the Big Island itself, shallow focus seismicity is mostly concentrated in the east and southwest rift zones. In these areas, large landslides are a hazard, which then have the potential of triggering major tsunami events. High-magnitude earthquakes from 6.0 to 7.0 in magnitude have also occurred here, including the 1975 7.4 magnitude Hawaii earthquake, among others. Seismicity in the Pacific Northwest is largely related to the Cascadia subduction zone. Shallow to deep focus earthquakes occur where the Juan de Fuca and Gorda oceanic plates are subducting beneath the continental portion of the North American plate. Landslides and tsunamis are potential hazards, as is liquefaction of sediments in low-lying areas of Puget Sound. High-magnitude earthquakes greater than 6.0 are common in the region. Notable examples include the 1700 8.7 to 9.2 magnitude Cascadia earthquake, the 2001 6.9 magnitude Nisqually earthquake, etc., etc. The mid-continent region of the United States experiences a great many earthquakes. This intraplate seismicity is due to reactivation of Precambrian faults buried beneath younger rock layers at or near the surface. An example is the New Madrid seismic zone, which exists due to fault movement related to the buried Reelfoot Rift. A few high-magnitude earthquakes greater than 7.0 have also occurred in this region, along with thousands of low-magnitude earthquakes in the past several decades alone. The 1812 7.2 to 8.2 magnitude New Madrid earthquake and the 1886 6.9 to 7.3 magnitude Charleston earthquake were the most powerful earthquakes ever recorded in the eastern United States. Arizona is no stranger to seismic activity. In southern Arizona, seismicity is mostly related to transform and extensional faulting in nearby California, Baja, and Sonora. In northern Arizona, seismicity is common on reactivated basement faults. This area is known as the Arizona Seismic Belt. Earthquake activity across the state consists of mostly low to moderate magnitude earthquakes, typically less than 5.0, with a few notable higher magnitude exceptions. And these include the 1887 7.6 magnitude Sonora earthquake, which occurred across the border from southeasternmost Arizona. This quake produced ground rupture and a scarp along the Pataikachi Fault. Also of note, the 1993 5.4 magnitude Valley earthquake, which hit near the Grand Canyon, and of course the 2015 4.1 magnitude Black Canyon City earthquake, which occurred just north of Phoenix. Well, that's all for now. Till next time.